The first generation leptons may also be considered or constituted with generic, prime, and mutually canceling flavored Rishon elements. As you see, these Rishon elements in this 3-element rightmost column of the first row compose an electron and comprises both generic and a prime Rishon element. Now, Rishon elements in the 3-element rightmost column, including the 3 additional rows, compose a neutrino and comprise a generic neutrino, a prime boson plus, and a neutral flavored boson minus. Now, just as before, an exchange of the prime element included in the first row, lepton here, and the third row, boson plus, will transform the electron and neutrino one into the other. So let's take a look at the quanta of these leptons. So first, we're looking at the electric charge. And we can see that the electric charge on each of the Rishon elements is displayed here, -1/3, -1/3, and -1/3 for the electron, giving us -1, which is consistent with the standard model. Now, on this generic neutrino, we have electron charges of 0. But included in the composition is this boson plus and this boson minus. And since the boson plus and boson minus cancel, then the 0 charge on the generic neutrino provides the electric charge for the neutrino. Now, let's take a look at the spin quanta. Just as before, each of the elements has a plus or minus 1/2. And for this electron here, we have -1/2 on 2 of the elements and plus 1/2 on 1 of the elements, giving us a -1/2 for the electron. And we'll see again whether the connection with the weak force is consistent for the leptons as it was for the quarks. And then for the neutrino, we have plus 1/2 on the two of the generic elements and a -1/2, giving us a plus 1/2 on the neutrino. And then for each of the bosons, we have plus and minus 1/2 on the elements, so they don't contribute anything to the spin quanta. So the spin quanta on the neutrino is then plus 1/2, and for the electron is minus 1/2. So let's see if we have consistent weak charges. And so since this was left 1/2, we were expecting there to be a weak charge. And we see we have a -1/3 and a -1/3, and then we have a 1/6. So the 1/6 cancels one of the -1/6s in the 2 -2/3, giving us a -3/6. So we have a -1/2 weak charge on the electron, which is consistent with the standard model. And then here on the neutrino, we have a -1/6 and a -1/6, summing with a third, which gives us a 0 on the right-handed neutrino, again predicted by the standard model. And here on the plus and minus bosons, we have opposite charges summing to 1 and -1. And so the weak charges prove consistent with the standard model. Okay, now, as said before, if we exchange the prime Rishon elements, here this V prime and this anti-T prime, then the electron and the neutrino should transform one into the other. And so here we have now the V prime up here where it says we now have a neutrino instead of an electron. And here we have the anti-prime T. Now this still says we have a neutrino, but let's look and see. We have a neutrino here, but we have a boson 0 here now, but we have a boson minus here. So this boson minus summing with these two and the generic neutrino will give us a -1 electric charge, which is consistent with the standard model for the electron. So now this composition here is the composition of the electron, though that composition includes a generic neutrino. It, with the boson 0 and boson minus, will give us a quantum, we'll see, for the electron. And here we have now the V prime, which has an electric charge of 2/3, canceling out the -2/3 on each of these anti-T rishons, giving us a 0 electric charge on the neutrino. Okay. Now we have the weak charge displayed. And the weak charge now on the generic neutrino has been transformed because there has been a vector boson emitted here. And so this was -17, and now it's +1/3, and this vector boson now has on it a -1/3 and a -17, giving us, carrying away the -1/2 and leaving us a +1/2 on the neutrino. But a +1/2 weak charge is inconsistent for the electron. But we see now we have 0 weak charge on the boson 0, but we still have a -1 on the boson minus. And so the -1 summed to the +1/2 will give of a -1/2 weak charge on the now composed electron, which is consistent with the standard model. And here we have still the +1/2 weak charge, but that +1/2 now is cancelled by the -1/2 on the vector boson 0, giving us a weak charge of 0 now on the neutrino. So let's see, that means we should have a right-hand spin here on this neutrino, and we should have a left-hand spin on this electron now composed of these 3 groups. And we can see now we had a -1/2 on this neutrino because we have 2 -1/2s, but we have a +1/2 on the vector boson, which gives us a +1/2, and which is consistent with the standard model, giving us a +1/2 weak charge and a +1/2 spin and a 0 weak charge on the neutrino. And then for here, we have a spin of -1/2 now. And of course, for the weak charge, we had a weak charge of -1/2. And so that is consistent with the weak charge we would expect to have on a -1/2 spin electron, which we have composed of these 3 groups here. And so, in a similar way to the composition of the quarks, we now have the composition of the leptons and the transformation of those by the exchanges of prime rishons. And as we consider our exploration, we will see how these prime rishons and these flavored rishons reconfigure to give us the generations of leptons and the generations of the quarks.